Assume that when adults with smartphones are randomly selected, 51% of them use them in meetings or classes. Good. If 6 adult smartphone users are randomly selected, find the probability that at least 3 of them use their smartphones in meetings or classes. Okay, the first thing that's important to note here is that this is a binomial probability problem. And the reason it's binomial is because it meets all of those criteria. So we have a fixed number of trials, 6 adult smartphone users are randomly selected. We have a fixed probability of success. For any one of them, the probability that they use that smartphone in class or meetings is always 51%. Those are independent trials because there's no relationship that we know between those people. So this is a binomial probability problem. And so at least 3 of them, so that tells us how many successes we're looking for. And even though we're using Excel to do the calculations, it's always a good idea to have paper and pencil out so you could sort of map out the problem and gather the information in a way that sort of tells you what to do. So for a problem like this, let's list the things that we know. So in a fixed number of trials, so there's 6 trials, 6 people are randomly selected. The probability of success is 0.51, that's the 51%. And the number of successes, well, let's see. Out of 6 people, how many of them could be using their phones in a meeting or class? Well, anywhere between none of them and 6 of them. So 0, 1, 2, 3, 4, 5, or 6. So at least 3 of them means 3 or more. So this is at least 3 of them. Okay, so the X values that we wanted, the number of successes that we're looking at is 3 or 4 or 5 or 6. Okay, Excel can't give you that directly. Excel could only work from starting with 0. So we're going to use the rule of complements here. So if we use the rule of complements, the probability of 3, 4, 5, or 6, well, that should be equal to 1 minus the probability of the rest. 1 minus the probability of 0 or 1 or 2. And so Excel could do this part because it's starting with 0. And so we'll use the binomial function for that. And we're going to use the complements rule. So 1 minus the probability of what we don't want will give us the probability of what we do want. Okay, I'm going to merge some cells together so you could see everything I'm typing. Okay, so to solve this problem, it should be equal to 1 minus the complement of at least 3. So binom dot dist, binomial distribution. The number of successes, so we want to go up to 2. So the X value is going to be 2, comma, the number of trials, that's given in the problem, that's 6. The probability of success, that's given 0.51, comma, and cumulative, cumulative is, do we want to use exactly X equals 2? In which case we would not use the cumulative function, or do we want to use everything up to 2? In this case we do. We want to use the cumulative function because we don't want X equals 2, we want X equals 0 or 1 or 2. So we'll say yes. So you could type the number 1 for true. You could use the mouse and select true. Either way, a 1 and the word true mean the same thing in Excel. So you could do that. Or what I usually do, since I'm it's only one keystroke instead of four. I usually just type the one. So either way, one or two doesn't matter. All right. And let's say, I don't know, let's say we want to round that to 3 decimal places. So we'll use the decrease decimal key up there in the toolbar. So the probability of at least 3, randomly selected people out of 6 using their smartphones is about 0.675. Okay, that does it for this problem. I hope it was helpful. Just before I go, one last thing. I just really want to stress all this writing that I did, especially over here and, this list over here. This is all stuff I recommend you doing. Even though you're using Excel, you should have, paper and pencil out with you to organize the information and sort of map out what you're doing. Okay. All right. Hope this was helpful.